Hi everybody, this is Nicole. Today we're going to talk about harmful algal blooms. I know it's not a super cheery subject, but it is a very interesting one. So we're going to talk about why our oceans turn brown and red certain times of the year, why there's sometimes sick and dead birds and marine mammals on the beaches, why are there warnings not to eat wild shellfish like mussels, and what's going on with all that. So the short answer to that is that HABs stands for harmful algal blooms. They're phytoplankton, and some of those phytoplankton carry toxins. And those toxins can magnify up the food chain to affect birds and whales and sea lions and, yep, even us. So when a little tiny plankton collects toxins that it actually makes itself, and then it is eaten by something a little bit bigger, and then something bigger eats a lot of those, and something bigger eats a lot of those, the toxin can actually accumulate and become a problem. So we call those harmful algal blooms when there's too many of those in our water. The longer answer, though, is that different phytoplankton react differently to different water conditions. So that's really the secret to when and if there will be a toxic or harmful algal bloom. So what is it that's contributing to some of these? Here in Monterey Bay, if you're an avid beach goer or ocean person, sometimes you might have seen these incredible flocks of birds that come here to our waters. These are the sooty shearwaters, among other birds that come here. These ones migrate all the way from New Zealand, and they come here because of the big blooms of plankton we have in our waters, which creates then food for copepods and krill, and that's what they feed on. This also feeds whales that come here to Monterey Bay. So the whales are coming to eat the krill and the anchovies. We have these humpback whales that come here in the fall, mostly feeding on anchovies. Here is a humpback chowing down in Monterey Bay on a bunch of anchovies. The blue whales come here too, and they also come in the fall, and they come here to feed on krill. And the krill are feeding on phytoplankton. So all those things are connected. Here's a picture though. Take a look at this humpback whale and look at the color of the water coming out of its mouth. You can see that it's kind of this weird yellowy orangey color. Here's another picture of that with waves being this weird color. That color is made by the pigments that the phytoplankton are using to capture the sun's energy. And in the case of some toxic algae, those pigments are often this brown color. Here's a picture from even up higher from a satellite image of that red color, that pigment that can be caused by mostly dinoflagellates. So in the spring here then, the wind comes and that brings cold water up to the surface and makes mixing, which provides the nutrients, little spelling error there, sorry, nutrients for plankton that they need in order to grow. The fall instead brings warm water here, and that water forms a layer on top of the cold water, and most of the phytoplankton can't move past that layer. So that means that they get trapped. But dinoflagellates, which is a type of phytoplankton that have flagella, can move, and they can move through it. That makes them superior competitors when the water is warm. So warmer water tends to favor these dinoflagellates, like these funky shaped ones here in the middle of that picture. Here's a picture of a windy, rough water. This creates a lot of that mixing, which brings those nutrients. That happens in the spring. So here's a graph that shows, look at the blue line here. The blue line is Pseudonychia, which is a diatom. And you can see that here in the springtime, it's really high compared to this dinoflagellate down here, which is much lower in abundance. That's Alexandrium. But look what happens here in the late summer and fall. Those diatoms plunge as the water gets warm. Dinoflagellate numbers go up. And that's because those dinoflagellates can move through those layers. Here's Alexandrium, which is a toxic dinoflagellate. It carries a toxin called saxitoxin. That's a group of toxins. Pseudonychia is a diatom that we have here, which is a diatom, not a dinoflagellate, but it does also carry toxins. It's one of the few diatoms that carries toxins. It carries a toxin called domoic acid, which is pretty famous or infamous here for causing the sea lions and the birds and stuff to wash up on the shore, kind of looking like they're drunk. So dinoflagellates can produce those toxins, which can lead to illness and death all the way up the food chain into the very highest organisms like the sea lions and even killer whales. So they can be really dangerous to marine systems. And they can also stink. I don't know how many of you have been to the beach in the fall sometimes when that brown water's around and it kind of smells funky. Most diatoms are not toxic, but one here, Pseudonychia, which we just talked about, is toxic and can produce this domoic acid. Those are all called HABs. So once again, why can dinoflagellates persist in warmer water? Part of that answer is because of these flagella they have. They can move. They can move against the density barriers that can be caused by water temperature differences. Cooler water holds more nutrients. And so they like to move down into that cool water to get the nutrients, then they can move back up to the surface to get to the sunlight. And diatoms can't do that. They get stuck in those barriers. So it's only when the water is mixed in the springtime that those diatoms tend to flourish. So in summary, spring usually brings wind and mixing and nutrients, which favors diatoms, and not many diatoms carry toxins. Fall instead brings warm water that creates those layers that the diatoms can't get through, and the dinoflagellates can. So fall tends to favor dinoflagellates. And dinoflagellates carry some pretty potent toxins, and there are more dinoflagellates that carry toxins than there are diatoms. And those can magnify up the food chain, so those can cause problems for us. So there you go. That's your brief introduction to HABs and harmful algal blooms and what times of year we tend to see them. I will add a little footnote here. We've been seeing those harmful algal blooms actually throughout the winter and even into the spring because our waters are getting warmer because of climate change. So this year, for example, we saw a lot of those toxic dinoflagellates all the way into very recently into the spring. So let's keep our eye out for it. Really important reason to monitor these things. See you soon.